have input devices, which we've done in the fundamentals. So I'm not going to disturb you, or we'll skip it. Output devices, we've done it. Central processing unit, we've done that partially in the introduction when we're looking at lecture 1, but there are some few things that maybe I will take you through again. So if you look at unit 4, we have central processing unit. That is introduction to the CPU. And we will look at the other components of the CPU, which include the arithmetic and logic unit, basically, that handles the logical operations or mathematical calculations. We'll look at the control unit, which is a major component that coordinates the activities of the other components of the computer system, registers, memory, and then finally, we'll look at the instruction cycle or instruction execution cycle. And basically, when it comes to the instruction cycle, we are looking at 4 main stages, which is the fetch, you decode, you execute, and then you store. That will be discussed as well. Then unit 5 will look at the instruction set architecture. Here we are looking at the definition and types of ISA, and the full meaning for ISA is instruction set architecture. Under that, after the definition, reviewing the types, we will also look at the distinction between the complex instruction set architecture and the reduced instruction set architecture. That will be discussed. We will also look at instruction formats and addressing modes. And more importantly, there's the need for us to discuss the memory as a topic. So we'll look at the primary memory. Basically, in computing, if you talk about the memory system, then we are looking at the random access memory and the read-only memory. I'll move further by looking at the cache memory, the virtual memory, and the secondary memory. Another vital topic within the context of computer architecture has to do with pipelining. So we'll look at the definition of pipelining hazards, and then solution, how we can solve it. And again, advanced CPU topics, where we are looking at the superscalar architecture, multi-core, multi-processor systems, vector processing. And if you look at the superscalar architecture, partially it will be discussed within the pipelining context or within that particular domain. Unit 9 has to do with performance metrics and evaluation, where we are looking at the clock speed and MIPS, FLOP, performance measurement techniques. All these things will be discussed under the performance metrics and evaluation. In terms of this one, should have even be units. If you look at definitely advanced computer architecture, where you are looking at the various architecture. So in a way, I'll talk about it briefly in unit 1, and then we'll look at the advanced forms of this particular. Finally, we have future trends in computer architecture. Future trends in computer architecture. This should be the outline, and I know or understand how your curriculum is. What it means is that we have to put in a lot of effort for us to be able to successfully complete all the topics listed here. So aside the input devices, the output devices that I'm not going to take you through, the rest of the items here, and if you look at the unit, we have about 11 units. So we are taking 2 out of it. The rest, we have to go through all these topics. And in that case, what I will do is that I will ask the course rep to give me some groups. You have to form some groups. And I'll give some topics. Course rep, are you here? David?
No, please, I'm here.
Yeah, is your assistant also here?
So, Doc, for now, we've merged the class, so maybe later by next week, we will appoint a new course rep.
When you
So
say
this
you've
one is
met
a merged class between June and then January intake.
Oh, I get it now.
Yeah.
Okay. That is why the numbers are quite huge.
Yeah.
Okay, right. Then you have to appoint one, and then based on the numbers that you have, I need about 8 groups. 8 groups. And these 8 groups, we are going to, so a group will present on unit 4. Are you taking notes? Another group will present on unit 5, unit 6, unit 7, unit 8, 9. So just the major headings or the major unit. You will distribute these topics to the various groups, and every group is expected to have a group leader and a group secretary. Every group should have a group leader and a group secretary. The topics, I'll be treating them, but I'm also giving it to you as a presentation. And that should be your mid-semester quiz or examination that we have to conduct. So I'll use the presentation for your mid-semester. What are the modalities for the PowerPoint or for the presentation? I expect that you use PowerPoint, which is the standard application for preparing a presentation. And in all cases, please note, the font style for the PowerPoint should be Tahoma. I repeat, the font style for the PowerPoint, the whole content should be Tahoma. Then the topics or the headings, if you take PowerPoint has it has headings and then subtitles. So please, the headings should be, the font size for the headings should be between 30 to 35. 30 to 35 for the font size. Then the content itself, which is the subtitle, the subtitle should be 25 to 28. 25 to 28. Please take note of this. These should be the things I'll be looking out for. And I expect that the first slide, you have the name of the university, the logo of the university, the topic you are presenting on. First of all, you should even have the course, which is computer architecture and organization, the topic you are presenting on. The next one should have the group members, their names and their ID. And your presentation should also have an outline. So if you are coming to present on instruction set architecture, what is the outline for the presentation? So maybe an introduction, you will talk about this, you will talk about that, you will talk about that, you will talk about that. These are the things I expect you to include in your presentation. For the benefit of those who miss it out, I'll repeat it again, I'll reiterate it again. I'm saying that your course reps or your course rep will create groups for me. I need 8 groups, and I don't know the number that will be in it. That one, I'm not really bothered about that. My main concern is that we have 8 groups, and every group should appoint a group leader and a group secretary. It is the duty of the group leaders and the group secretaries or the group secretary to call for meetings. It can be face-to-face, it can be online, for you to prepare towards the presentation. And all the group leaders and secretaries will have to take note or take attendance, such that once you call for meeting once, twice, and a student is not showing up, or one of your member is not showing up, please take the person off, inform the course rep, and he will form his own group. That should be very, very simple. Very simple. So 8 groups, and for the number, I'm not bothered, as I stated. Now let's go to the PowerPoint. As I stated earlier on, the PowerPoint, the font style for the PowerPoint should be Tahoma. The PowerPoint should include the name, logo, course, topic, and then group members. Font size for headings should be 30 to 35. Subtitle or the content itself should be between 25 to 28. And then you also add line spacing, which should be 1.5. Line spacing should be 1.5. Do you have any question, please? Any question?
No, please.
Okay. So no from your end. Let's find out from your other colleagues if they also have any question to ask. If there's none, today is the first day. I'm going to do something brief, and then we can call it a day. So I'm still waiting for questions. Okay. If there are no questions, then I think we can start the discussion and do something brief before I sign off. So, computer organization and architecture, week 1 and week 2, we are looking at basic concept and computer evolution. Basic concept and computer evolution. So I spoke about some outline, that your presentation should have an outline. And if you look at it, I have an outline for my presentation over here. So I have a brief introduction. Then we will look at some definitions of terms. definition of computer architecture, the basic structure, ISA approach, generations of computers, which is not new to you because you did that in fundamentals of computing. Classifications of computers was done in fundamentals of computing. That's the good aspect of having some of these introductory or fundamental courses. Instruction cycle, embedded computer systems, and cloud computing. I'll also share the reference book or the book for this particular course. I'll share with you so that you can also use that as a guide, aside the manual that I developed for computer architecture. Now let's look at some terminologies. Structure. What is structure? Static arrangement of any object or any item. Static arrangement. And when we say static, I'm sure that at this level you all understand what static is. Organization in itself means dynamic interaction of the parts and their control. Implementation, on the other hand, looks at design of specific building blocks. Performance looks at behavioral study of the system and its component. So these are some terms that will frequently occur in our discussion. What is an architecture? An interface between layers. An interface between layers. Now let's go on to computer architecture. So a computer can be defined as an electronic device that accepts data as input, process, stores, and gives an expected output. Now we just define an architecture as an interface between layers. Linking. Now we want to look at computer architecture. It is a set of rules and methods highlighted. Rules and methods that describe one. If you look at the computer system, if I ask you, I hope you can hear me. I just saw.
Yes, we can hear you.
Yes, sir, we can hear you.
Okay. I just want to. I just saw a notification that my internet is unstable. Maybe I'm just running out of data. Let me buy more. Then we can. I do not want us to break or have a break anywhere. Let me quickly do that. Then we can continue. Of rules and methods that describe the functionality. Rules, protocols, methods that describe the functionality. What are the functionalities of the computer system? Based on the definition that I provided earlier, you and I can simply identify, four main functionalities. It takes inputs as data, or takes data as input, takes data as input, processing, storage, and output. That describes the functionality, how the computer is organized, and then the implementation of the computer system. And I like the second definition. It defines the design methodology or method. You see, the first one said the rules and methods. Here said the design method of how computer hardware, what is computer hardware? A computer hardware, I want to assume that you've forgotten about it, is a peripheral, or they are the peripheral, or the physical component of the computer system that we can see and also touch. And anytime we mention the computer hardware, it can be discussed from 5 main perspectives. What are these? We can talk about input devices, processing devices, storage devices, output devices, distribution or communication devices. So hardware can be looked at from 5 main perspectives. So the design method of how the computer hardware component interacts, how they interact with each other, based on the challenges imposed by real-world components and technology. Based on the challenges imposed. Imposed by what? Based on the challenges imposed by real-world components and technology. Very sorry about that. Let me log off the WhatsApp on my laptop so that it does not disturb. Great. Now, so in summary, computer architecture refers to those attributes of a system that are visible to the programmer, or attributes that have direct impact on the logical execution of a program. And I'm sure this definition will be long for you. So I'm sure most of you will prefer the first two. And for me, I'm in love with the second one, which is even the first one is also okay, a set of rules and methods that describe the functionality, organization, and implementation of the computer system. So what are the basic structure? Computer architecture in general covers 3 aspects of the computer design. 3 aspects. 1, the computer hardware. And that is what I explained just a few minutes ago. How did I define the hardware, or how did I describe the hardware? I said it is the physical component of the computer system that you can see and also what? Touch. And I said we have 5 main categories: input, processing, storage, output, and distribution. The next one has to do with what? So it consists of the electronic circuit, display magnet, and optical storage media and communication facility. What is computer organization? It refers to the operational unit and their interconnection. So an example can be the control signals, interface between the various peripherals, and the memory technology being used. So we are looking at the key component or the basic structure: computer hardware, computer organization, and then the instruction set architecture. So look at that. instruction set. What is an instruction set? An instruction set, which is ISA, it defines the interface. And when we say interface, just look at the operating system. What are the interface of the operating system? We have two main types or two main interface. We have the command user interface, which is also known as the character user interface, and the graphical user interface. So the operating system makes it possible for you and I, who are the users, to interface with the computer system. So an instruction set architecture defines the interface between the software and the hardware. You will notice that all the keywords within the content here, I always try to explain it. I'll assume that you have forgotten your discussion, the discussion on software. What is a software? Set of instructions. Basic categories or basic types. We have the system software and the application software. Which one comes first? Let's talk about the system software. And the system software, we have the operating system, we have the utility programs. Some will add device drivers, and all other books will put device drivers under utility, and then programming language. So an instruction set architecture defines the interface between the software and the hardware. More importantly, or alternatively, it defines the communication rules between the major category or the major component of the computer system, which is the hardware and the software. It defines the communication rules, how the hardware interact with the software, how they communicate with each other. So you are working in, or you are using an application, MS Word. You are done typing, you are done doing with your work, and you want to print. If you issue the command in MS Word, how is that feedback or that signal sent to the computer? How they communicate, how the software applications communicate with the various hardware. So let's proceed. With that concept, then we can talk about the complex instruction set and the reduced instruction set. Please remember, we are discussing the basic structure. I repeat, computer architecture in general covers three aspects of computer design, which is the computer hardware, the computer set architecture, and computer organization. I've explained the hardware, I've explained the computer organization, currently explaining the instruction set architecture. Again, instruction set architecture. Remember, I said there are two main approaches: the reduced instruction set architecture or computers, and then complex instruction set computers. Let's deal with the complex instruction set computers. And look at it. Remember, here, when we're defining, it said what? Define the interface between the instruction set. When we defines the communication rule between the hardware and software. Let's look at this. The complex instruction set. It is a design practice that focuses, and the points are highlighted, multi-step instructions. So these type of computers deal, or they are designed to handle multi-step instructions that are complex. And because of that, we have very power-consuming hardware because of their nature, because of their design principles. So their design focus on hardware components and what? Binary instruction complexity. In summary, the complex instruction set computers are designed only to execute complex and powerful instructions. And I've given some examples over here. The IBM 360/370. These computers are designed to handle or to execute. And in computing, when we say execute, you understand or you know what is execute. So they will only deal with complex and powerful instructions, multi-step instructions. Reduced instruction sets. If you look at, that's going to be a reverse of the complex instruction set computer. Look at that. They are focused on simple. The complex is focused on what? If you remember, multi-step instruction. The reduce is focused on simple, quickly executed instructions. This one is focused on what? Complex instructions. These are some of the distinction between the complex instruction set computers and the reduced set instruction. So, simple, quickly executed instructions, and what is the objective? To improve efficiency and reduce power consumption. Remember when I was looking at the complex, we said they are power consuming hardware. Why? Because they deal with complex instructions or multi-step instructions. So their hardware are designed to handle such issues. So it is a type of computer that uses small, simple, and efficient set of instructions. I repeat, it is a type of computer that uses small, simple, and efficient set of instructions. So unlike the complex that are focused on complex hardware components, this one simple hardware component, and they reduce the binary instruction. Look at this one. It said these designs focus on hardware component and binary instruction complexity. This one handles what? Reduce binary instruction complexity. Just as I gave you an example for the complex, over here as well, we have some examples for the reduced instruction set computer. Any question? Can I proceed?
Yes.
Yes, sir.
Okay. Thank you. So aside, sorry, I have a code. I have some code for the past day, so forgive me about my voice. For the other instruction set approaches, so the main ones are the ones I just reviewed with you, which is the complex and reducing. But there are other approaches, which is the control unit, which is not too new to you. So on the control unit of the CPU receives information from the software, then it distributes and directs the data to the relevant hardware component. When it comes to the arithmetic and logic unit, that's you and I, we know that it handles all the arithmetic and logical or logic operations. So these are some architecture when it comes to the computers. The first one we can talk about is the IBM system, the 370 architecture. And that was introduced in 1970. It included a number of models. It could be upgraded to a more expensive, faster model without having to abandon the original software. New models were introduced later. And look, the architecture has survived to this day as the architecture of IBM's mainframe product line. Listen to that. This architecture has survived to this day as the architecture of IBM mainframe product line. So now, there's the need for me to clearly help you or for us to distinguish between computer organization and computer architecture. It is very, very important that we know the distinction between computer organization and computer architecture. So computer organization is often called the microarchitecture. It is at the lower level. Computer architecture is at a higher level. Again, computer architecture is transparent from the programmer. So here, a programmer would not worry how much additions are implemented in the hardware. When it comes to computer architecture, programmer view, it means the programmer has to be aware of which instruction sets are used. The programmer has to be aware of the instruction sets that are used. Computer architecture deals with physical components, circuit design, signals, peripherals. This one deals with what? Logic, instruction set, addressing mode, data types, cache optimization. And these are topics that we'll be looking at. Finally, computer organization is all about how to do it, the implementation of the architecture. Sorry. And computer architecture, what to do, the instruction, what to do, how to do, implementation, and what to do. So I don't think I have to bore you on this particular lecture when it comes to the generations of computers, because you and I have gone through some of these and the fundamentals of computing. What are the generations? The first generation, where they use vacuum tubes. The second generation, transistors. Third generation, integrated circuit. We move to microprocessors, and currently we are in the era of what? Artificial intelligence. These has been the these are the 5 main generations of computers. So I'm not going to waste your time on it. So this is a picture depicting the first generation. These were the vacuum tubes that were used. and the punch cards, the paper tape that were used as input and output operations. Remember, I'm not saying input and output devices. They were used as input and output operations. These were some of the features, or these are some of the features of the first generation. Vacuum tubes, they're very big, consumes a lot of electricity, so failure level was high. Input and output operations were punch cards, paper tapes, and all that. The speed was measured in milliseconds. We moved to the second generation, where transistors were used, the core memory was developed, and it was also faster than the first generation. The first operating system was introduced. They used machine language, which is also known as the binary digit or binary code. We are looking at the zeros and ones. Magnetic tapes were used. Third generation integrated circuits. Speed was in nanoseconds. And more importantly, they used high-level language. What is the difference between low-level language and high-level language? Low-level languages are machine-dependent. High-level language are human-dependent. In other words, that's a language that we understand. The language of the computer is the low-level language or the machine language. So for the third generation, high-level language or high-level programming languages were used, such as the Fortran, the COBOL, the Pascal. We move to the fourth generation. Again, microprocessors, high-level languages. So these were getting closer. Talk about the C, the C++, and all that. Currently, we are in the era of what? Artificial intelligence. So robotics, machine learning, speech recognition, and all that. Additionally, we also looked at the classifications of computers, and that was discussed in fundamentals of computer. So remember, we have three main categories. We have classification by type, classification by size, by purpose. And if you are looking at classification by purpose, we are looking at general purpose computers, special purpose computers. By size, we are looking at the supercomputer, the mainframe, the mini, the micro. So I don't have to go through the later ones. Use discrete or distinct values, which are represented by zeros and ones. The 0 means off, the 1 means what? On. And we spoke about the analog that uses continuous range of values. Continuous range of values. So the main distinction between the analog and digital one is that the analog uses continuous range of values. This one uses discrete or distinct values. Please get it clear. The hybrid would combine the features of the two that we looked at. In terms of classification by size and capability, I'm rushing because I've done it already, and I see it as some form of revision for you. Supercomputers are the largest, the fastest, most powerful, and most expensive computers ever made. I am more interested in their application. They are used for scientific, or they are applied. Mainly, primary or the main component or main use is for scientific application. The mainframe, they are less powerful and a bit cheaper than the supercomputer, and they are used for scientific and business application. So payroll computations, accounting, business transaction, information retrieval, airline seat reservation. We can move to the mini computers, the microcomputers, which is the last one, and then they are small, low cost, and single user computers. So basically, that's it. And this gives us a diagram of the functional unit of the computer system. I don't have to explain the input, output, and it is because of this that is why we have a whole topic on input and output model, the memory control unit, and the arithmetic and logic unit. Let me touch on this and then we can call it a day. Instruction cycle. Basically, this is the instruction cycle as stated in my introduction or review of the outline. We have fetch, we have decode, we have execute, and then we have store. I repeat, we have fetch, decode, execute, and store. What happens at the fetch stage? At the fetch stage, the word is fetch. So instructions are fetched from the memory of the computer. At this stage, instructions are fetched or read from the memory of the computer system. That's simple. Instructions. So if you look at the diagram, fetching the instructions. At the decode phase, what happens? The instructions that were fetched from the memory are now broken down into smaller units, into smaller components. Why? This is to ascertain the type of operation to be performed. I repeat, 1, the instructions are fetched from the memory of the computer. At the decode phase, the instructions are broken down into smaller units or smaller parts. Why? That will help us to ascertain the kind or the type of operation to be performed. When we say execute, the other word is to run. At this stage, remember the instruction has been fetched. Decode, we know the action to be performed. It means the command or that instruction has to be executed. By what? The CPU. And when we are done with everything, we can now store it for future use. Or that is stored back into the computer memory. So we have fetch, decode, execute, and store. Don't forget that. The first stage, you are fetching the instructions from the memory of the computer. The second one, the instructions are broken down into units. And that is to help us to ascertain the type of operation to be performed. The execute phase, what happens? The commands or the instructions that were fetched are now executed or run, and then store, they are kept. Those that have been worked on are now kept for future use. Colleagues, we will wrap up here and continue, God willing, next week. Thank you. So I'll upload this letter 1 on the learning management system and also share with your course rep as well. Thank you for joining.
You're welcome.
Thank you, sir.
Thank you, Dr. Kudjo.
Enjoy the rest of the day, please.
Thank you, sir.
All right.
All right. Thank you very much.
Bye.
Bye.
Mike.
Yeah, Minia.
Hey, how are you?
Kalomo record the M3 hour.
I'm doing come.
Chaso.
Go and get prepared for 10 o'clock.